Why are all planets in the universe spherical? Whether it's Earth, the Moon, or other planets, their shapes are almost perfectly spherical. This isn't a coincidence, but rather the result of one of the most fundamental forces in the universe. When a celestial body has enough mass, the gravitational force inside it acts evenly from all directions on every part of the body. This uniform force pulls the material inward and forces the body to take on a shape that reaches a state of pressure balance. And this state is a sphere. In physics, this phenomenon is called hydrostatic equilibrium. It refers to the stable shape that a rotating fluid celestial body reaches due to the combined effects of internal pressure and its own gravity. In this state, gravity pulls every point on the surface of the body toward the center, and only a spherical shape can ensure that the gravitational forces from all directions are symmetrical and balanced. Therefore, celestial bodies with sufficient mass will eventually take on a nearly spherical shape. It's important to note that not all celestial bodies are perfect spheres. For example, planets that rotate quickly may experience centrifugal forces, causing their equators to slightly bulge, resulting in an oblate shape. Earth itself is a classic example of this. However, this distortion is very small in scale and doesn't change the overall trend of these bodies being close to spherical. On the other hand, smaller bodies like asteroids and comets don't form spheres. This is because their mass isn't large enough to generate the force required to compress them into a spherical shape. In other words, only when a celestial body reaches a certain mass threshold can its own gravity overcome the rigidity of its material and shape it into a sphere. Thus, the spherical shape of planets we observe is simply the natural result of physical laws at a large scale. In simple terms, planets in the universe are spherical because this is the most stable shape under the influence of gravity.